For Chapter 3, I've chosen several problems. The first one I'm going to look at is problem number 5. Problem number 5 gives you an airplane, 50 seats, 55 tickets sold, of course. And here's the probability that 45 people show up, that 46 people show up, 47, and so forth. So the first question asks, what's the probability that the flight will accommodate all of the ticketed passengers who show up? So that means probability that 45 show up plus, because if 45 show up, it works. Everybody gets a seat. Probability of 46 plus probability that 47 show up. And now notice this is 45 or, which is plus, or 46 or 47, blah, 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 until you get all the way up to the probability of 50. And each of these values is listed underneath here. I'm just going to add up those values, and I end up with what's sitting there. So that would be plus 0.05 plus 0.10 plus blah, 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 until you get to 50. This one here. Because this is the number that we're talking about. This is where everybody gets a seat right there. Alright, what's the probability that not all ticketed passengers who show up can be accommodated? So that means 51 or 52 or 53, 54. That means those show up. So probability of 51 showing up, got problems, plus probability of 52 all the way up to probability of 55. Adding up those probabilities in our chart, 0.06 plus 0.05 plus blah, blah, blah. You add them up and you would get the 0.17. C question says, you're the first on the standby list, which means that you'll be the first one to get a seat on the plane. So, okay, I guess that means 49 or under show up. You will get a seat. So it would be probability of 45 plus 46 plus 47. Or I guess you could just take the answer that we got in A and subtract out 0.17. So you could, because I added that one in, and that one doesn't need to be included because if 50 people show up, you won't get a seat. So it's actually, either way you work, it's going to get the same thing. So it's the probability of 45 plus blah, 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 all the way up to the probability of 49, or you can do that subtraction as I talked about earlier. What's the probability? What's this probability if you're the third person? Okay, so 49 if you're the first. There's the second person, third person. So I need the probability of 45, 46, or 47. The probability of 45, or probability of 46, or probability of 47. And add up those numbers. And you would get the 0.27. The next problem I chose was problem number 9. It's kind of a messy and definitely long problem. You'll have to figure out, it's not necessarily hard, but it is tedious, probability of 0. That means that both of them show up on Wednesday. So that would be the probability of Wednesday, and that would be multiplied probability of Wednesday. So for this first one, I would get 0.3 times 0.3, and that's how I got the 0.9. Probability of 1. Now this is going to be kind of a little chart. I'm just going to do it like this. This means probability of a Wednesday and a Thursday, or probability, and we have two magazines, so I have to remember that it could be a Thursday for the other one, and probability of a Wednesday for the second one, or They could both get there on Thursday. So it's a messy. Probability of the Wednesday was 0.3 times Thursday 0.34 plus 0.34, got my numbers now, times 0.3 plus 0.34 times 0.34, and then if you'll do that multiplication, you'll get what's sitting up there for probability of 1. Probability of 2 gets really long. This would be the probability of a Wednesday and a Friday, or a Friday and, trying to write too fast when you slow down, Wednesday, or probability of a Thursday and a Friday, or Friday and a Thursday, or, can't write fast enough, Thursday, or probability of Friday, probability of a Friday. And then I would just plug in those numbers and crunch that out in my calculator. So just plug in the numbers for the 0.3 times 0.15 plus 0.15. Of course, you could simplify this a little bit by just calling this one times 2 plus dot, 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 and carrying on. And then the probability of 3 would be similar, it's just my list would be even longer. Let's assume that for this first one we wanted to find the probability of exactly x equal to 2. Then you would use a PDF. But let's say you wanted to find the probability of x less than or equal to 2. You would use the CDF, because what the CDF does is it finds the probability of 0, adds to that the probability of 1, and then adds to that the probability of 2. So you could, if you wanted to, do 3 separate calculations. Instead of using a CDF, you could just use a PDF every time, but instead of that they have a cumulative, which makes problems a lot easier, because what if they wanted x less than or equal to 90? Then that would be very tedious. So be sure and read through the notes and work through the example that I have listed in your notes, and that should help you in entering problems into the calculator. Now this is kind of what I expect on your test. I expect for you to do something of this sort. You would look at this problem and you would decide that it's binomial, and they want for you to find the probability that x is less than or equal to 2. So I'm going to use a binomial CDF, and the number of trials, or my n, is 20. My p, or my probability, is 0.1, and I want less than or equal to 2, so I'm just going to put a 2 in there. And if you'll do that, you get the exact answer from your calculator is what's listed. Now to try to figure out how to go the other way, because this says the probability that x is greater than or equal to 5, that means that if I plug it in my calculator with this last value being a 5, I won't get what I'm looking for, because I'll get the probability that x was less than or equal to 5. So I actually want the probability of 0, 1, 2, 3, or 4. So I could do this directly using my calculator, using a binom CDF 20.1, and instead of using a 5, I'll use a 4. Now this won't get me what I want, this will get me all of that less than 5. So this gets me less than 5. So to do greater than 5, I will just say 1 minus this value. and then I'll get the answer 0.043. Now I want the probability of 1 to 4, so that means I want the probability of 1, or the probability of 2, or the probability of 3, or the probability of 4. You could do a binomial PDF 4 times. Just do it 4 times, get an answer for each one of these, and then just add them up. Or you could get the value for 4, which I got in the previous answer, and then subtract out the binomial for 0. It's another way to do it. They both seem about equally as tedious. What's the probability that none? So this is the probability of 0. So we actually want a binomial PDF. PDF where n is 20, probability is 0.1, and we want a 0 here. Expected value, that's just n times your p. So that would be my n is 20, probability is 0.1. For my standard deviation for a binomial, it's npq. So that would be the square root of n is 20, probability is 0.1, and q is the opposite of that probability, or 1 minus p, which would be 0.9, and if you crunch those numbers, you'll get what's sitting there. The next problem I chose for you was problem number 27, and it is a Poisson distribution. I copied down for you, once again I snagged out of my notes. If you'll print those off, I have this listed plus an example of how to work this into your calculator. That's what these instructions here for. Whoops. So these instructions right here. This one is for, and I chose a line instead of the pen. That one is for my PDF distribution, and this one is for cumulative distribution and what the entries on those look like. Very similar to the binomial entry on your calculator. You're going to, second distribution again, you're going to look up Poisson PDF for this one because I want exactly 2. So PDF, and your lambda in this case, which is your mean, is 0.2. And we want to know exactly 1. Plug that into your TI-84 and you'll get the 0.164. Probability of at least 2 means 2, 3, 4, 5, and on and on and on. So I'm not going to do all of those. Instead, what I'm going to do is 1 minus the probability of 0, and also minus the probability of 1, and that would give me at least 2. So I can use, if you want, a Poisson distribution where I say 1 minus Poisson, and instead of using a PDF, I'm going to use a CDF because it does 1 and back, and so I'll use 0.2 comma 1, crunch that in your calculator, and you would get your answer. Let's see, if 2 differ independently, what's the probability that neither? So that means the probability of 0, and then the probability of 0. So I'll just do the Poisson distribution, PDF, and then I'll just square my answer. And that would be 0.2 comma 0, and then just square that answer and you'll get it.